So this will be the condition when he's walking, no? So it'll be like this. So when he just landing is like, I think when you just, okay, there's a left leg, there's a right leg. When the left leg, when it is just landing on the ground, I think the friction will be here. And when it's taking off, so this is the landing leg. Take off. When this is taking off, the direction of friction will change. But altogether, I can just put like, say, whatever the case, like F2 will be greater than F1. When specific leg, when it's taking off, its friction will be greater. So now suppose say it may be that there's a left leg. There's a right leg. After this, what will happen? The left leg will be taking off and the right leg will be landing, no? In that case, what we get is like and all. The left leg friction will be F2 forward and this will be F1 backward. But the resultant friction, the friction at the landing leg will be less than the friction at the takeoff leg. So don't say that always the friction at the left leg will be less compared to that one. I think all of you know walking. So here rather than saying left or right, no, so I'll just put in this way. This is a better idea. The friction at the takeoff leg will be more than the friction at the landing leg. So therefore the resultant friction on the person will be acting forward. So in what direction he moves, in that direction the friction will be acting. I think you can experience. Provided if you walk on the some ground, not on the granite, no, there you don't feel, at least on carpet. If you walk that one, and you can see that one, and when you are barefoot you walk it, not on shoes or something. Barefoot you try to walk and make observation. You can experience that one. Okay, now the net frictional force on the person should be in the direction of its motion. That's the one conclusion we can make it. The net will be in the direction of motion. Direction of is motion. Okay, now what are the types of numericals we can expect here, like based on this? Okay, let me take a situation. There's a plank I placed and let there be a person. I have to show he is walking. To study this friction, this walking is what, like, is a like a controlled oscillating, controlled toppling is called as a walking. When you are walking, so what will happen to your body? Body will swing, no? Left, right, left, right. So if the person is there, if he's walking, the body what happen will try to swing like this. So controlled toppling is nothing but walking. So to analyze this in depth, we need a toppling idea that will come in rotation mechanics. The idea of the toppling has to be brought into the picture. Now at this level you can just only proceed with this basic idea. So now there's a plank of mass 3m, person is mass m. This is there. Definitely, and the quotient of friction between the plank and the inclined plane, let it be 0.5. and tan theta I'll give 37. So what is the find the minimum acceleration of the person who is sliding, who is walking on the plank, so that the plank should not slide. What happens if the person is at rest? Tan theta is greater than mu. Check it. Tan 37 is greater than mu in fact. So the plank will slide here. For that not to slide, the person is going to walk. With what should be the minimum acceleration of the person so that the plank will be at rest with respect to incline? This is the question. A plank of mass 3m.
Sir, once can you repeat question?
I write it down, my dear. Is kept on rough inclined plane and a man of mass m walks down the incline, walks down the plank. Okay, now find the minimum acceleration of person so that plank will not slide. Okay, I have brought all the questions. Now you can ask one question, sir. You're not giving friction between the person and the plank. Coefficient of friction should be given. No, what is given? Only the coefficient of friction between the plank and the inclined plane is given. This should be smooth or rough. If the ground is smooth, can you walk? Not possible, no. Not possible. We can't walk. So therefore, it should be rough. You need not to mention.
If not,
person
will
walking.
slide not sir.
Person walking. Listen to me. Person walking on the plank. If his walk is able to walk, means it must be rough. Okay. I need not to mention also. It is naturally. It's like understood that if person walking on a surface means the surface must be rough. Okay. Now, what is the diagram now? This is about the go for free body diagram. There is inclined plane. Inclined plane will be fixed. Let's go for the forces acting. I'll show it everything here only. It's a very small problem. Work out. Get all the different forces that are acting. The weight of the person, mg sine theta. Then the friction. F1, I'll write it. Then 3mg sine theta. Then the friction here should be such that minimum acceleration is asking. F1 and F2. So now the person will accelerate. He should accelerate. He should run down. And then what is the plank? Plank should not move. Should be at rest. Now what about the normal contact? Will be N1. This will be N1. Oh. Let's write it. 3 mg sine theta. This n2. Let me equate the forces. Perpendicular to incline n minus 3 mg cos theta, no?
Yes, sir, cos theta.
I can remove like this. Mg cos theta, unable to show it. Diagram will be very, or okay. Now this is equal to now n1 so on the person will write the forces mg sine theta minus f1 equal to ma. It's asking that acceleration. N2 equal to 4 mg cos theta. We'll get this much. Okay, there's a one equation. Then what are the forces acting on the plank? We'll see. F1
Sir, friction acting on man should be in forward direction, right, sir?
okay, correct. Now this is friction on the person forward, on the plank should be upward. Arrows correct? Yeah, fine. So what is the equation now? Mg sine theta plus will be there. Then f1 plus f2 minus 3 mg sine theta. Okay, yeah, thank you. F1 plus f2 we don't know f1. Okay, I'll substitute f1 value from the first equation there. This f1 should be equal to ma minus mg sine theta plus f2 minus 3 mg sine theta equal to 0. ma is equal to f2 4 mg sine theta minus f2. What shall I do with f2? Minimum acceleration is telling. So what is the maximum permitted value of f2? Mu n2. Maximum permitted value when a is a minimum, f2 will become f2l. What is f2l? Mu n2. Mu, what is the value of n2? N2 will be 4 mg cos theta. Let me substitute that. A minimum, this f2l. f2l equal to mu 4 mg cos theta. Solve this, we'll get that minimum acceleration. Anybody?
8, sir.
8. Sir, why you are writing a minimum and f2l? Any reason? Like the way you are writing this. We are trying to link this one, no? Because the acceleration will be minimum when friction force acting is maximum, no? So when the plank is about to slide, then that is what the minimum acceleration. Okay, this is a person. Okay, now we have time till one more problem we'll have. Huh? Write down all this one. I'll go for one more problem.